Hello and welcome back. In this video we're going to do a lot of simplifying. We're going to simplify monomial exponential terms. We're going to simplify some radicals. So let's get started. For number 1 here, notice we have 12 divided by 3. That's going to give us a 4. So we'll always try to simplify the constants first. It makes it a little bit easier. Now we got x squared on the top and x to the 4th on the bottom. You can think of that as 2 x's being multiplied on the top and 4 x's on the bottom. Notice that 2 will cancel on the top and bottom, leaving us with 2 on the bottom. So that's a way you can think of this simplifying. So that's number 1. For number 2, everything gets squared. Everything gets squared. So we're simply going to have a 9x to the 4th. Because x squared squared is x to the 4th. The exponents get multiplied here. The denominator will have y to the 8th. And that is all the way simplified. Look at number 3. We have a negative exponent. We can turn negative exponent positive by putting it in a denominator. And then we still have to square everything in the denominator, giving us 1 over 9x squared. That is our simplified answer. Alright, let's look at some more here. 4, 5, and 6. Now we got 2 more exponentials, and then we start with our radicals. Alright, when multiplying exponential terms, we add the exponents. So, x to the 3rd, x to the 6th becomes x to the 9th. Y to the 4th, y to the 7th, 7 plus 4 is 11. Alright, oh, then we got number 5. Sorry about that. Number 5, we start simplifying radicals. Now, when you simplify radicals, you want one of the factors to be a perfect square, and you want even exponents. Okay, so I'm just going to rewrite number 5 here for just a minute. 16 is a perfect square. We're good there. A squared, even exponent. But notice b to the 3rd. I'm going to rewrite it as b to the 2nd times b to the 1st. Basically, if it's an odd exponent, I just lower it by 1 and have an extra 1 out here. So we can take the square root of 16 and we'll put it out in front. That's 4. We'll take the square root of a squared and put it out in front. That's just a. Square root of b squared is b. And then we still have this b left inside the radical. So the final simplified answer here is 4ab radical b, or square root of b if you want to say it. On number 6, 32 is not a perfect square. However, it breaks down into 16 times 2. See, we want to break a number down into factors, and one of the factors should be a big perfect square as possible. We can take the square root of the 16. We can take the square root of the x squared. But the 2 here is going to stay put. Square root of 2. We're going to have 4x outside of the radical. Alright, let's look at some more. 7, 8, and 9 here. Okay. 75. Notice how 75 breaks down. 25 times 3. X to the 4th is already a perfect square, even exponent. Y to the 3rd, we're going to turn that into y squared and y. Z to the 6th is already a even exponent, so we're good. We can take the square root of this, 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 and this. So we'll have 5x squared y, z to the 3rd. And inside the radical is the stuff we didn't mess with, the 3 and the y. And there's our simplified answer. If you look at number 8 here, 9's a perfect square. We're going to leave him alone. X to the 5th will become x to the 4th times x. Y to the 4th is an even exponent, so we're good there. Take the square root of this, this, and this. That's going to give us 3x squared, y squared, and we're left with a radical x. Good. All right, we're back to exponential terms. Basically everything inside the parentheses will get raised to the third power. 3 to the third is 27. And then the exponents get multiplied. We have x to the 15th and y to the 21st. And that's the simplified exponential term there. Let's look at some more. Now let's see if we can fit all this in. And I'll move it up here. All right, let's focus on 10 and 11 here. All right, let's turn that -2 exponent into a +2. So put it under 1, 2x to the 4th still, and it is now being raised to the +2 power. All right, 2 squared is 4, x to the 4th squared becomes x to the 8th. Final answer, 1 over 4, x to the 8th. All right, now on this one, notice that negative exponent, it's only happening to the x but not the 3. 3 is going to stay put, but if we just shove that x into the denominator, it'll become x to the +5. And we're good there. All right, let's scroll up and look at the others. 12 and 13, 12 and 13. Okay. Focus on the the constant terms. We have a 3 over a 21. All right, so from a fractional point of view, that's going to reduce to 1 over 7. When you have division, quotient situation, you can actually subtract the exponents. -2 minus -8 for the exponents on x, becomes x to the +6 in the numerator. Okay, but here's something I can do now. Think of it like this. Here, I'll show this step. -2 minus 7 actually gives us y to the -9, but I need to put that y in the denominator to turn that -9 exponent into a +1. So what we're going to have here, I'm not going to write the 1, I'm going to have x to the 6th over 7 y to the 9th. That is our simplified term. All right, let's do the same thing on 13. Notice, focus on the 27 and the 30. Let's reduce that fraction first. They both can divide by 3. 27 divided by 3 is 9. 30 divided by 3 is 10. All right, focus on the x's, -3 minus 7, x to the -10. I'll move him in a little bit. There's no exponent on the y, but it's there. It's a 1. And 1 minus -2 is y to the 3rd power. The only thing left to do is to put that x in the denominator. So we have 9y to the 3rd, 10x to the 10th power. See, when you move something from the numerator to the denominator or vice versa, it changes the sign of the exponent. All right, let's look at a few more simplifications here. Okay, these are 14 and 15, a little bit different. What's going on here is we're dividing a polynomial by a monomial. So basically, we can rewrite, notice all the terms here in the numerator. Got a 45x to the 7th. I'm going to break that down and have that over the 9x squared. I have 36x to the 4th, and that's over the 9x squared. See, basically I can put that 9x squared over each term individually, and I'll just simplify from there. And I'm going to run out of room a little bit here, so I'm going to have to write a little smaller. Sorry about that. 45 over 9 is 5. X to the 7th, x to the 2nd becomes x to the 5th. 36 over 9 is 4. X to the 4th over x squared becomes x squared. 2 over 9 just stays 2 over 9, but I have an x on top and an x squared on the bottom, so I'm going to have 2 over 9x. That is my simplified answer here. Let's do this last one here. 20x to the 8th over 4x to the 3rd. Then I'm going to have 28 x to the 5th over 4x to the third minus 44x to the fourth over 4x to the third. And then we simplify. 20 over 4 is 5. X to the eighth, x to the third, I'll have x to the fifth. 28 over 4 is 7. X to the fifth, x to the third, simplifies to x to the second. 44 over 4 becomes 11, and then I just have 11x because 4 minus 3 is 1. It's really an x to the 1 power. Don't have to write that 1 exponent if you don't want to. All right, these now last two, just want to point out a couple things. They're considered exponential functions. Notice where the exponent is. The exponent is up here. It's a variable, okay? So these are exponential functions, and what we want to focus on, you certainly can graph these. I recommend graphing them on Desmos. But what we're focused on here is the number inside the parentheses, the base of the exponent for both of these, and we just want to classify and point these out. Are they exponential decay or exponential growth? If that number that we're pointing to, okay, here let's just look at a general form of an exponential. Let's say y equals b to the x, okay? And here's the rule basically. If b is greater than 1, then it's considered exponential growth. But if b is less than 1, it's considered exponential decay. All right, so if you look at number 16, focus on, don't worry about the 4, but focus on what's in the parentheses there. We got a 1/2, and notice the 1/2 is less than 1. So this one is actually exponential decay. If we were to graph it and look at it from left to right, the function actually goes down. The y values go down. It decreases in value as you go from left to right on the x-axis. But look at number 17. Now 5 over 2 looks like a fraction. It might be a little misleading, but we could rewrite that as 2.5. And we notice our base here is greater than 1. So guess what? Number 17 here would be considered exponential growth. If we were to graph that function, and you might want to take a look at it on Desmos, graph it and notice the y values from left to right. They increase, they grow, they get higher. That's why we call it exponential growth. All right, I hope these helped you. We talked about simplifying exponential terms. We simplified radicals. We talked a little bit about exponential growth and decay here on these last two examples. Thank you for watching.